Show the complete step-by-step mechanism for the Fischer esterification reaction between ethanoic acid and ethanol. Okay, so this is one method of making esters. So we start with the ethanoic acid or acetic acid, OH. We have two lone pairs on that oxygen there, and we are using a catalytic amount of H+. Okay, so one of the lone pairs on that oxygen grabs the H+, and this is what you get. CH3, C double bond O, one lone pair, and now you have a covalent bond to hydrogen, and you still have this OH here. Now, if you do the formal charges, you should have a positive charge on that oxygen. Next, what happens is, so right now this carbon here is very, very electron deficient. So a molecule of ethanol, CH2, CH3, will attack that C double bond O carbon. Okay, attack, and then carbon can only have 4 bonds, so what is going to happen is that one of those 2 bonds there will go to oxygen as a second lone pair, and this is what you get next. CH3, C double bond O. Oh, sorry. Now that there is only going to be a single bond, and now you have 2 lone pairs on that oxygen, and you still have this OH here, and now you have a covalent bond between this carbon and the O of the ethanol O, CH2, CH3. You still have an H there, right? And you still have 1 lone pair on that oxygen. So now the plus charge now is at that oxygen. Okay, so what happens next is this here lone pair on the OH grabs that H on your O, CH2, CH3, and that there bond between the oxygen and the hydrogen goes to oxygen as a second lone pair, and this is what you get. CH3, CO, and now you have 2 H's bonded to that hydrogen. You still have 1 lone pair, and you still have this OH, and now you have this O, CH2, CH3, and you do have 2 lone pairs on that oxygen. And now the plus charge is right there. Okay, what happens is that oxygen is very unhappy. So what happens is that bond between the carbon and the oxygen goes to oxygen as a second lone pair, and this is what you get. CH3, COH, O, CH2, CH3. Now we have a positive charge on that carbon. We do have 2 lone pairs there. We do have 2 lone pairs on that oxygen. Okay, we're almost there. Okay, so that carbon is positively charged. So what happens next is, even though ethanol, the oxygen on ethanol is not very basic, it's basic enough to remove that H off of that oxygen there. So CH3, CH2OH, another molecule of ethanol. So that lone pair, one of the lone pairs on that oxygen grabs that H, and what happens is the bond between the O and the H goes to O as you form a second bond between the carbon and the oxygen, and finally you form your product, C double bond O. This is a CH3, and then down here you have O, CH2, CH3. So if you would just redraw that, that will be CH3, C double bond O, O, CH2, CH3. And now we have our ester product.